Another video answering a common question. I've actually answered this a few times on the discussion board, but I will make a video as well to try to clarify this. This is an old exam, winter 2022. You get this messy third derivative and you have to get an upper bound. And I get lots of questions about this. The question on the discussion board said, why didn't they just plug in 0.5? I'm going to come back to that, but just note, I'm going to say a few general things first. So I already posted this link. I'm just adding a comment. So I have a long discussion here about this, posted about it a few times. But let's pull up one particular thing. So how do we find M? Let's see if I can get this over. So a common question is, how do we maximize? And that's kind of an overarching problem or theme some students are having, is they've forgotten how to optimize. But there are some shortcuts, and we've been talking about those. So think of it this way. If you can't give a quick justification for why the maximum is at an endpoint, do not plug in an endpoint. Don't just automatically plug in endpoints. That's the main issue I'm seeing. So let's recap the situations we've seen. We've seen a lot of examples. In fact, most of the homework was an increasing or decreasing function, which meant the maximum was at an endpoint. One example from homework was this. It said find an upper bound for this, which was some derivative, and you had to realize that its maximum when the denominator is smallest. So, I don't want to say more because it's going to be long enough anyways. But you just plugged in a 3. Same goes for like e to the x, which is an increasing function, or e to the negative x, which is a decreasing function. So a lot of your homework, yes, it was an endpoint. But that was just because we immediately knew it was an endpoint. If you don't immediately know, then more thing is needed. We need to do a little bit more. If it's a trig function, so particularly sine and cosine, then I know it doesn't even matter what the interval is. I know that this sine stuff is between -1 and 1, which means that this is less than or equal to 7. That's it. Don't plug in an endpoint. That's completely wrong there. Okay, what happens as things get more complicated? As things get more complicated, there is a very slim chance that the maximum is at an endpoint. So what do? Well, we break it into pieces. The question is not asking for the global max. It's just asking for something that you know is bigger. So basically you say, what's the biggest this can be? What's the biggest this can be? What's the biggest this can be? And we switch gears to being a little less precise. And then you add those things together. That's the idea. I have more posts on this. If you really want to dig deeper, I even talk about what do we do with minuses. I do lots of discussion. That's way more than you need. I give a full explanation of this problem. But I just wanted to address in a video the particular question that was being asked. So students said, I don't understand why you can't just plug in 0.5. So I thought I would just show you. So here's the thing we're trying to find a maximum for. To me, it's way too complicated. There's nothing that tells me the answer is at 0.5. But in this case, it's just dead wrong. So here, let's look. If you plug in 0.5, you get 5.74. Is that an upper bound? Let me get rid of everything else so you can see it. Is 5.75 an upper bound? No, it's not. It's not the highest the function gets. The highest the function gets is right there. Now, finding that is nearer to impossible. We're not asking you to find that. We're asking you to find some upper bound. Now, if I had this picture, and it's not the other endpoint either. If I had this picture, I'm trying to find where this is. So it's not this endpoint. It's not this endpoint. It's somewhere here. So the best upper bound is 8.85. And I have no good way to find that. So what do? We break it into pieces. We ask ourselves, what's the biggest this can be? And what's the biggest this can be? And we just pretend it's as if it's two separate problems. And the part that people are confused about is we then add them together. A lot of students say, why don't you subtract? You don't subtract because we're dealing with positives and negatives, and depending on which one's positive and which one's negative, it could be large. So just because you have the maximum of both numbers doesn't mean when you subtract, it's going to be bigger than the absolute value. In fact, it could be worse. It could be negative. If you have like 4 and 10, you subtract, you're going to get negative 6, and that's definitely not an upper bound. So in general, I give a longer post about that if you want to explore. I talk about that here. I give a thought experiment about why we can't say this and why we say this instead. That's way more than you need. But the point of the problem was this. So let's go back and look at the post. What the person did that was doing this problem was saying, okay, this function's too complicated. We don't know the maximum, but we do know that this term is less than 8e, and we know that this is less than 16. Now, what is 8e plus 16? I did not plan this. So if we did 8e plus 16, it's 37. It's way too big. So let's make this 37. We accept that. Yes, it's an upper bound. It was just the thing that I could get quickly. Now, in this case, it might work at the subtraction. I'm still not confident. Might get lucky. The best bound, the tightest bound, is like I said, that 8.8. But it is definitely not the endpoints. You lose points if you just plug in the endpoints. All right, I hope that explains.